Welcome to the pH and pOH calculations tutorial. Here we are able to convert to find pH, pOH, and the concentrations of the hydronium and hydroxide. Hydronium is related to pH, which the chemical equation is H3O+. Hydroxide is related to pOH, which is OH-. And both of these are concentrations. Here are 5 basic formulas which we need to have memorized. Negative log is a function in our calculator that you just plug in, and H3O plus is a concentration value, so moles per liter. So depending on the question, we have to pick the right formula to have our numbers plug in correctly. Here we have a C-shaped box that is helpful to memorize to know how to get from one equation to the next. Also, significant digits are a little different for pH and pOH, but remain the same rule for concentration values. The number in front of the decimal are not significant for pH and pOH values. The ones underlined are the only ones that are considered significant, and the ones in front of the decimal don't matter. So for the first one, we have 1 sig dig. For the second one, we have 2. And the third one, we have 3, looking at the numbers only after the decimal. Here, for example, we're given a concentration of 3.0 times 10 to the negative 2 mole per liter, which is 2 significant digits. So when calculating for the pH, you're given 1.52287 continuous, but knowing that we only need 2, we keep 2 numbers after the decimal. So we have 1.52, as the 1 does not count, as it only holds the place value of the number. So here we're going to talk about pH and pOH scales and how we know when something is acidic or basic. So starting with pH, on our scale from 0, 7, and 14, we know that 0 to 7 is acidic, 7 is neutral, and 7 to 14 is basic. And going on to pOH, which is a little bit backwards from pH, with the same scale of 0, 7, and 14, opposite from pH, 7 to 14 is now acidic and 0 to 7 is basic, but 7 remains neutral. So by using that, when you're given a pH or pOH, you can tell when something is acidic, basic, or neutral. So let's do a practice question now. So we want to find the pH of 0.12 moles per liter of lithium hydroxide. So the first step would be to write out the chemical equation. So starting with lithium hydroxide, which breaks apart into its elements, which is lithium and hydroxide. So by writing out the information, which is 0.12 moles per liter, which is a concentration, so that would be our H3O plus. And looking at the formulas we need to find the pH, so we're going to use the top one there and use negative log to the concentration to plug in. So writing out our equation, we know that we have 0.12 moles per liter, so plug that in, and then you punch that into your calculator, giving you a long continuous number, but we only have 2 significant digits, so we just do 0.92, and also there are no units involved with pH or pOH. So here, moving on to the next question, we need to calculate the OH in limes, which have an H plus of 1.3 times 10 to the negative 2 moles per liter. So writing out our information, which we are given the H plus, and we want to convert it to pH to begin with. So plugging in that number to your log function, you're given a big pH, and it is important to remember to keep it into your calculator, all the decimals, to give you the most accurate number. Also, on a side note, H plus and H3O plus are the same thing. It's the same concentration. So moving on, we need to find the pOH. So minusing our pH from 14 gives you the pOH, which gives you a long number. So lastly, to get the OH concentration, writing out the formula, which is 10 to the negative pOH, You plug that into your calculator, which gives you a long number, but using the right number of sig digs, you're given 7.7 times 10 to the negative 13 moles per liter. Also, units are very important for concentration, so just remember to put those down. So moving on to a more complicated question, we are going to find what mass of strontium hydroxide needs to be dissolved in 3.0 liters of water to create a solution with a pH of 8.34. So we want to write down our chemical equation to start off. So we are given strontium hydroxide, which breaks out to its elements, giving you Sr2+ and 2 OH ions. Since we are given a pH and our equation contains OH, it is a base, so we must find the pOH or OH concentration to get to the correct mass. So writing out the information we have, which we are given a pH of 8.34, we need to convert it to the pOH, so we subtract that from 14, giving you 5.66. So given that, we can now find the OH concentration. So we plug in our pOH to the formula, 10 to the negative 5.66, which gives us 2.18 times 10 to the negative 6 moles per liter. So that's our concentration. So given that, we now need to do some unit analysis. So starting with our non-ratio number, which is 3.0 liters. So using our 3.0 liters, we're going to write that out, and we're going to use the concentration that we found earlier and put the liters on the bottom so they will cancel out and the moles on the top. And since we are looking for the entire mass of strontium hydroxide, we need to convert our just OH into the entire thing. So using the molar ratio, we put 2 moles of OH that we found in our equation on the bottom and 1 mole of strontium hydroxide on the top. So the OH moles cancel out and you're just left with the strontium hydroxide. And to find the mass, you're going to put moles on the bottom. We're using the molar mass, so grams per mole, and we find the mass of strontium hydroxide, which is 121.64 per 1 mole. So canceling out our moles, we are just left with grams, which gives us an answer of 4.0 times 10 to the negative 4 grams of strontium hydroxide, using the right number of sig digs coming from the 3.0 liters.